All right, let's talk about something we all think we know inside and out. Something we're told we need more of every single day: water. We see it as the essence of life itself. But what if I told you that, in the right, or maybe the wrong, circumstances, it can be a deadly poison? Let's get into it.
And no, this isn't some hypothetical scenario. This is a real, tragic headline. A young woman, a mother, joined a radio contest with a ridiculous name: Hold Your Wee for a Wee. The whole point was to chug as much water as you could without using the restroom. And she did it. She won the game console for her kids. But just a few hours later, she was dead.
So that's the big question, right? How on earth can water become a killer? It just doesn't seem to make any sense. Well, to figure this out, we need to go deep inside our own bodies. I'm talking down to the cellular level. Because there's this incredible, delicate balancing act happening inside of you right this second.
Okay, so to really solve the mystery of how water can kill, we first have to put a name to the culprit. Let's look at the science behind this unthinkable tragedy.
The official medical term is hyponatremia, and if you break it down, hypo just means low, and natremia is all about sodium. So it literally means low sodium in your blood. It's what happens when you drink so much plain water, so fast, that you completely dilute the essential salts your body needs to function.
But, before we get into how that system can fail so catastrophically, we first need to appreciate how it's supposed to work. Because every single day, your body's pulling off this amazing feat of engineering just to keep everything perfectly, and I mean perfectly, balanced. On a totally normal day, you lose around 2.5 liters of water. And it's not just from the obvious places, like sweating or going to the bathroom. Get this, you're actually losing water right now, just by breathing. Every time you exhale, a little bit of water vapor goes with it. It's this constant, invisible loss that means we have to have a constant supply coming in.
So how do we get those 2.5 liters back? Well, it's not just from what you drink. Sure, that's about 60% of it. But a pretty big chunk, almost 30%, comes from the food you eat. And your own body, believe it or not, actually makes about 12% all by itself, just through its normal metabolic processes. It's a real group effort.
Now, your brain is like mission control for this entire operation. It's constantly sampling your blood, checking the concentration of stuff like salt. The second that salt concentration gets even a tiny bit too high, bam, it flips the thirst switch. So here's the key thing. You don't just get thirsty when you're low on water, you get thirsty when your salt-to-water ratio is off balance.
And if the brain is mission control, then your kidneys, man, they are the unsung heroes of this whole story. The amount of work they do is just staggering. They filter about 190 liters of blood every single day. To put that in perspective, that's like filtering an entire bathtub full of liquid. And from all that work, they precisely manage the output, producing just 1.5 liters of urine, all to keep your body in that perfect equilibrium.
Okay, so we've seen the big picture. Now let's zoom way in, because when this careful balance is thrown off, the real danger, at first, isn't to your body as a whole. It's to every single one of your trillions of tiny cells.
This is what we're aiming for. It's called an isotonic state. You can just think of it as a happy cell. The amount of water and salt inside the cell is perfectly balanced with the fluid outside the cell. Water flows in and out at the same rate. Everything's stable, healthy, and working just as it should.
Now, this is hyponatremia on a microscopic scale. When you drink way too much plain water, the liquid outside your cells gets super diluted. This is a hypotonic state. And because of a fundamental process in biology called osmosis, water automatically rushes from that diluted area into the saltier area inside the cell, trying to even things out. The result? The cell swells up like a water balloon, and if it gets too full, it can literally burst.
And just to complete the picture, this is the exact opposite problem. What happens during dehydration? We call this a hypertonic state. There's now too much salt and not enough water outside the cell. So osmosis does its thing in reverse, and water rushes out of the cell, causing it to shrivel up and shrink. As you can see, both extremes are incredibly dangerous. So our body is in this constant fight to stay right in that isotonic sweet spot. The scientific name for this whole process is osmoregulation. Let's take a look at how it works in a couple of really extreme situations.
Think about a really intense workout. You're sweating a lot, right? Well, that sweat isn't just water. It's also packed with essential salts. You've probably heard them called electrolytes. So your body kicks into high gear. Your kidneys start conserving water, and your brain is screaming at you to drink something. And that's the whole reason sports drinks were invented. They don't just give you water back. They give you those crucial salts you've lost.
helping you get back to that balanced, isotonic state.
You want a truly brilliant example of osmoregulation in action? Just look at fish. A freshwater fish lives in what's basically a hypotonic world. Its body is way saltier than the water around it, so water is constantly flooding into its system. Its solution? It almost never drinks, and it produces a ton of urine. Now, a saltwater fish has the exact opposite problem. It's swimming in a super salty, hypertonic ocean, so it's constantly losing water to its environment. Its solution? It drinks seawater all the time and uses special cells in its gills to pump all that extra salt out. Two opposite problems, two totally brilliant evolutionary solutions to maintain balance.
And that brings us all the way back to that radio contest and its tragic ending. Now that we understand all the science behind it, we can see exactly what went wrong.
So there it is again, hyponatremia. The woman in the contest drank gallons and gallons of plain, solute-free water in an incredibly short amount of time. Her kidneys, as amazing as they are, just couldn't keep up. They were completely overwhelmed and simply could not get rid of the excess water fast enough.
But here's the absolute cruelest part. Her body's own safety systems were tricked and turned against her. The flood of water diluted her blood so much that the normal communication system between her brain and kidneys broke down. A hormone that tells the kidneys to conserve water basically got stuck in the on position. So even while her cells were swelling to a dangerous degree, her body was being told to hold on to even more water. It was this swelling, especially in her brain, that led to the intense headache she reported and ultimately to her death.
So, the big takeaway here is that life itself exists in this incredibly delicate balance. Too little of something is bad, of course, but too much can be just as deadly. It's a biological principle called homeostasis. And it really makes you wonder, doesn't it? What other things we think of as totally essential and good for us, become dangerous when we push that balance too far? Definitely something to think about.